Hi guys, so today we are talking about this notion of alpha, and I want to really distinguish between alpha and p-values, which I talked about in a separate video, and that's actually one of the reasons why I am presenting it separately. So alpha. Alpha is what I'd like to call the threshold significance level. And it's a quantity that is determined by the person doing the statistics. It is somewhat arbitrary in that there's nothing magical about the particular value, but it is set in a way that it is used to judge the meaning of p-values. And it's something that's set in advance typically. So before you do your tests, you set your alpha level, and before you do your statistics, and before that statistic has an associated p-value, you say to yourself, I believe that in this kind of test, it will be a reasonable thing for me to say that I have statistical significance when when the p-value is below a certain value of alpha. And typical values of alpha that are set in the literature range from 0.1 to 0.05 to 0.01, sometimes even as low as 0.001. I've seen them go even farther than that in terms of this threshold significance level. Okay, so it's not a p-value, it's what we compare the p-value to. So it is a probability, and we are going to compare our p-value that we get with our associated statistic to it. So we are going to ask, is p less than alpha? And if so, then we are going to claim statistical significance. And if the answer is no, then we're going to say it's not significant. So this is the way in which it acts as a threshold, because depending upon our answer to this question, we will either have a significant statistic or a not significant statistic in terms of testing our null hypothesis. Remember what we're always doing with these statistics. We have a null hypothesis, and when we get a certain p-value, we can either reject or accept the null hypothesis. So when we reject it, we're saying it's statistically significant, and that we are going to talk about it as if there is, for example, a difference, if that's what our test happens to be about. Okay, so we sometimes set alpha at different levels depending upon how conservative or liberal we want to be. Now, setting alpha at 0.1 means that for any given test, we're going to quite often reject that null hypothesis, right? In fact, we'll be rejecting it quite a bit of the time. This is called a liberal test. It's not politically liberal or anything like that. It just means that we are allowing quite a wide range of p-values to be statistically significant. So we're liberal in that sense. We're tolerant of quite a wide range of p-values. And if we set p equals 0.01, this is a very conservative test. Note we're doing the same test, but it's just that we are being conservative by setting the p-value at 0.001, because that means that we are being very strict in what we are going to recognize as significant or not. Okay. Now, the most often chosen alpha level or threshold significance level is 0.05. What is magical about 0.05? There's absolutely nothing magical about this. I think it has mostly to do with a comfort level in being wrong. Now, if you think about that, so if we have a p of 0.05, what does that mean? That means that 5% of the time, if we said that was significant, that means that about 5% of the time we would be rejecting the null hypothesis, when in fact it's true. Remember our definition of p-value. Okay, so if we had a p of 0.05, that means that we are actually wrong in rejecting the null hypothesis 1 out of 20 times. And that means we're right 19 out of 20 times in rejecting it. And generally that feels somehow right, that we're right 95% of the time, depending upon what kind of test we're doing. If we're actually doing a very critical test where being wrong has huge consequences, we might not want to set p, that alpha, that high. P is what it is, right? But on the other hand, if our consequences of being wrong aren't that important, and in fact it's more important that we not miss a real difference, we might set alpha equal to 0.1. So it depends on the kind of test we're doing, whether you want to perform a liberal test or a conservative test. So alpha is our threshold significance level that we compare p to by asking, is p less than our critical threshold or not? And here's how we judge it. Yes, we get statistical significance. No, it's not significant. The value we choose for alpha is arbitrary. The other thing I want to say about that, though, is that there are standards in certain fields. So that many fields, alpha 0.05 is kind of an accepted standard for that particular kind of test. Maybe even within fields there are differences depending upon what kind of test you're doing. So it's just important to understand the field and the culture of the area you're working in biology in order to know how to set your alpha level. So that's where a statistician can't really help you. You as a biologist need to understand by reading lots of publications and looking at what is accepted as a reasonable threshold in that field for those kinds of tests. And you need to know that as a biologist. A statistician won't know that kind of thing. Okay? So that's alpha, and note how different it is from p-value. It is something that you determine as an investigator a priori. So it's a term I'm going to use more and explain more in other videos, but we just set alpha a priori, and it's determined by us. And then the p-value is something determined by SAS-Jump with our data in hand, and we compare those two values. Okay, that's it, guys. You understand alpha and p perfectly now.